So for our second example, we're going to work with solving a side, side, side. So with the last one, it seemed kind of intuitive that we would find the side across from A, and then we'd have a known ratio. But here we have side, side, side. So maybe we're going to have to find an angle to have a known ratio. Let's see. So if we open this up, it says use the law of cosines to find the angle opposite the longest side. So I guessed right. Of course, I'm the teacher. Okay, so you're going to find the angle opposite the longest side. So that is going to matter. Just like up here with the shorter, it matters. It's going to change your answer. And I'm sure you don't want to know why. So let's see what our problem is going to be. We're going to have three side lengths. A is 6 units, B is 9, and C is 4. So we can sketch out this triangle. I don't know if it's really going to look like that. I just thought I'd draw it fun. Okay, so we've got angle A, angle B, and angle C. And across from A is going to be 6 units, across from B is going to be 9, and across from C is going to be 4. So we can see we're missing the 3 angles, and it says find the angle opposite the longest side. So we're going to be finding angle B first. And I'm going to go ahead and highlight B. It matches up with our step 1 highlighting. So I'm going to write out my law of cosines then. And we're going to be using the second one, but remember they're all really the same. They just wrote out 3 different ones so that if you do go by the lettering, you won't get confused. But basically, we're going to plug in our side length that's across from B, the angle we're finding, over here. So side B is 9 squared equals our other side length squared and added together minus 2 times these 2 side lengths we just wrote in times cosine of B. And notice these are the law of cosines, so they use cosine, not sine. It's a subtle but important difference. So now we're going to solve. So I'm going to go ahead and square all these. So I get 81 equals, this is going to be 16 plus 36, which is 52, minus 8 times 6 is 48 cosine of B. And I'm putting parentheses around cosine of B so you remember it's a unit. It's a number on its own. So now we have to do some solving of the equation. We're going to have to move our constant and then divide by our coefficient. So 81 minus 42 is 29. And then 29 divided by negative 48 equals cosine of B. What a mess. Yuck. Alright, so now we have to do the inverse cosine on both sides. I'm going to type that in my handy dandy calculator. And let's see what happens. We had 127 degrees. So I'm going to put B as approximately 127 degrees. Alright, so that one we know for sure that is B. So now we have a known ratio. So it says use the law of sines to find a second angle. So we're going to go, I guess, up here because I'm running out of room. And we're going to say 9 over sine of 127 degrees equals, and apparently we can find either side, either angle that we want. I'm going to go ahead and find C. I'll find A. I'll find A. I don't know why it matters. I'm just being goofy. Okay, so sine A. I'm going to cross multiply and divide, and I have to do the inverse sign. And you can write out all those notes, but I'm just going to write A is approximately. I know I'm going to do inverse sine. I cross multiply and have 6 times sine of 127, and that's divided by 9. And I get 32 degrees, approximately. Now remember, this is kind of like skill 32. We're finding 2 missing angles. So technically, this is a sub 1. So if I go and find a sub 2 in the second quadrant by doing 180 minus 32, I can see that's going to be 148 degrees. Now, can these two angles be in the same triangle? No. Sorry, they can't. So that doesn't even affect anything. But you should always check just in case, because it could. So that's a sub 1, or we don't really even need to say a sub 1 anymore. And lastly, we're going to find the third angle, which is easy. We just do C is approximately. We know that all these angles need to add up to 180, so we're going to do 180 minus 127 minus 32, which is approximately 21 degrees. And we are done. And that's it. So, like I said, these problems, they just take practice. You've got to do a lot of them, and you'll get better and better and better. So good luck, and we'll work on these tomorrow.